Yeah, quick introduction. Talga, ASX listed, although we also trade over the counter in the US and in Europe. Market cap at the moment's just under 500 million. I'm the founder of it. I'm also the largest shareholder, so a bit of skin in the game. You can say we're fairly well aligned, and some other nice ESG-based institutions on the register, except for the fifth one, which is Yandal Investments. Some of you may know here in Perth is Mr. Mark Creasy. I'm not sure if Mark's ESG-based, but he certainly likes money. Finally, EVs take off. You now have data, so I'm sure we don't have to keep repeating ourselves for the last 10 years, those of us that started getting into the battery industry then. And what you're seeing, of course, is governments legislate it, which is not, so it's not just a demand pull, it's legislated as well. So it's starting to roll out quite quickly now. And I think in my world, to be honest, probably the sign of the final capitulator, and that was Toyota recently sort of getting almost forced, kicking and screaming to come along as well. But everyone else has been getting with the program for a while, quietly, and now it's having to go public. And they're actually now seeing the sales data themselves to support it, not just of Tesla's, but Volkswagen's sales data, the new Fords, like the electric Mustang, all these things, that they're actually seeing really, really good numbers. In fact, those sort of Ford saw those pre-sales very similar to what Tesla saw for the Cybertruck, and it's pretty big commitments early on. So it's a new model, and they're trying to work out now how to build all this out. They, to be honest, haven't thought that through yet very much. They've been taking too long and hoping that they could push it off and squeeze more life out of their existing assets. So what's happening is, of course, the supply chain for this. So the problem is it's way faster to build a battery factory than it is to build the stuff that goes into it, the supply chain. So battery factories, I'm going to get in trouble all over the world for this, but battery factories essentially assemble stuff, right? You bring them together and you wrap them up into the right package. And I'm not saying it isn't without skill, and it certainly costs a lot of money, but that doesn't take that long to do. You buy enough equipment, you bring it together, and you can do it. The problem is all the material that goes into it, as you probably in this room know, the supply chain is a lot slower to build. And one of the unsung parts of that story, while we very much, of course, appreciate all the cathode side in all the other metals of the battery, the other half of the battery, the anode, is a non-metal called graphite, which does this very specific job. And all of the battery factories around the world are needing almost half of the active material to be this stuff called graphite. And everyone assumes there's plenty of it. The problem is today, the global market is about 2 million tonnes of combined natural and synthetic. And of that, it's all industrial. There's only a small fraction of it going into batteries. And yet over the next 9 years, you need 4 million plus tonnes of the finished product, which would mean you would need to start with about 8 million tonnes of original material. So you're talking about 4 times global current supply of all types, including industrial, just to go into this one application. So you're seeing a massive revolution, and that's why the World Bank a few days ago had graphite as #1 on its list of the minerals going into batteries that will undergo the greatest amount of volume demand change. So and that's why we got into the business, which bases us in Europe. Europe is not the largest market in the world, but it's #2, but it's growing the fastest. They've got to go from 0 to a lot of capacity very quickly. So both Asian existing battery manufacturers and local Europeans. It was very heartening to see Northvolt going to be taking some lithium from here in my home state. That's really cool. And of course, Northvolt are about 1 hour drive down the road from our operation in Sweden. So we've based ourselves around a world-class asset that happens to be extremely close to where the bulk of manufacturing is getting done very quickly. And to say that the network of interest in green energy amongst all the governments is an understatement. So within Europe, they need to go from currently 0 production of anodes to over 700,000 tonnes of material. And in fact, a recent announcement by Volkswagen and Northvolt are taking that to over 900,000 tonnes of anode. That's over 40 times what our stage 1 production is planned to be. And it's, to be honest, every time we plan and permit for something, the demand just keeps overwhelming us. About a year or so ago, we announced that we had expressions of interest for over 3 times our annual production, and that, you could imagine, has increased remarkably from there. So the opportunity for us was to build anodes for lithium-ion batteries within Europe. And you could look at how to do that from synthetic material, but synthetic graphite uses petroleum products. It uses needle coke, and it's extremely energy intensive. So it's a fairly dirty supply chain. The material in your batteries right now are all coming from that background. It's a needle coke and huge amounts of energy with a lot of CO2. You would want to produce it somewhere with a lot of hydropower or wind. You'd want to have sustainable energy. You wouldn't want it to be being made on coal-powered energy grids in some countries. And also you'd want a short supply chain. As we've seen with not only COVID, but the Suez blockage, shall we say, and other issues, and look at container prices these days, the whole world supply chains are being revealed for being a little more fragile than people thought. So we have a resource in Sweden, but we've been piloting our own metallurgical processes for processing our ore in Germany and producing materials already for the last few years into the supply chain. When people test the final material for batteries, not the specs and the metals along the way, but when they take a final active product, they have to test it in their battery extensively. So we need to scale up operations to do that, and we've been doing that in Sweden and in Germany, and also we have technology labs in Cambridge in the UK, where we have our own scientists. So what we are doing is a little different. We're not just doing the mining and the concentrating and the purifying and the shaping, we're also doing the coating. So we produce a product that goes directly to battery manufacturers. And in this way, we capture where most of the value is in that supply chain is down the end. It's in the coating and the technology of being the final anode producer. In this way, our position in the supply chain is very similar to a Mitsubishi Chemical or a Hitachi Chemical. It's essentially setting up that from scratch. So yes, there is a mine with a concentrator, but then there's an anode refinery which has got purification and coating steps in it, and you produce the final anode product to go to a customer. So we've proposed building, we have a PFS with one out there to build just under 20,000 tonnes. That's enough to do about 16 gigawatt hours of batteries, and we've got a plan, a scoping study that's underway that's increasing up to just over 100,000 tonnes of anode. So what that means is would be about 80 gigawatt hours by the end of the decade. And already the demand is continuously overwhelming that, so we need to look at getting larger. So we have those studies underway, and we currently have got an electric vehicle anode plant under construction for making larger scale anodes in Sweden. And so it's just a continuous story of growth. Every time we plan, as I said, and try and implement something, it gets bigger and bigger. The big difference with our offering compared to an Asian supply chain is the emission signature, is the cleanliness of our material. Because we have a very high grade resource, it's about 25% resource grade, and because this means you do a lot less tonnes, our initial production comes from 100,000 tonnes of ore compared to 2 million tonnes per ore in other countries. So we have a much smaller footprint, and we're using all sustainable energy. And the power costs are very low. They're around 3 to 4 cents US per kilowatt hour, and it's all 100% hydro with some wind there. So compared to the existing supply chain that's coming in exclusively from Asia on coal powered with ex-petro products, it's very, very clean. So in this way, we're not just providing material to be competitive on price and performance, we're also providing a solution for car groups that need to get fossil free by a certain time, or they might be in the Paris Agreement. So we provide a solution where they can decarbonise with our carbon, as it were. And essentially, because we make that anode product, we make different anode products. So we have a silicon-enriched product. We also have a solid-state product. So we have different technologies that we can surf as these new types of batteries come in. We can actually provide practical, commercial scale options for them within Europe, so we're not really sort of kept out. We've had a lot of comments in the last few months, I guess, or in the last year. Solid-state batteries have been a big trend within the industry on paper. It's very, very difficult to solve. We actually have got our chief battery scientist is Toyota's ex-head of solid-state battery development for their hybrids, and so we've got a pretty good handle on that, and we've actually made a lower cost, practical, scalable way to make anodes for solid-state batteries compared to lithium metal. So there'll be a mix of everything, but the point being, just because you have a solid-state or a silicon technology doesn't mean you don't have graphite. In fact, most of those technologies still have a predominance of graphite as the main ingredient on the anode, for example. So how are we going to pay for this? I'm glad you asked. LKAB, the state mining arm of Sweden, and Mitsui, we are currently in negotiations for joint venture development of the project. The agreements we have with them, one of them does expire at the end of this month, but it's extendable, and we're currently completing a DFS on the project, which is due at the end of this month, and you can understand that would be the basis for continuing valuation type discussions on project development with them. Mitsui, of course, has got a lot of good downstream contacts, and LKB have got amazing synergistic potential for us. We're near the Kiruna iron ore mine, which they own, and the Sapavara operation. There's incredible synergies around transport, around people, around energy, around co-location, around energy sharing, around heat transfer between operations, chemical sharing, and things that will absolutely revolutionise the production cost and the operating situation there. We already interface with customers like Pharisis and pretty much all the major brand names you've seen today. We interface directly with and are in qualification programs with them on our anode materials in their batteries. We also do a lot of R&D type work on these new materials, which includes a lot of development with Faraday, winning Faraday grants out of the UK. The UK technologically has been a great place to develop our materials out of Cambridge and then to take them to the market. We're not from the university, but we share a lot of infrastructure there, and there's good technology flow. And we're members of most of the European Union Green Deal and green money sort of flows that are starting to happen. So we expect to have pretty well-priced financing for the delta between our development partners and Talga itself going forward. We've previously done advanced materials announcements with Jaguar Land Rover, Bentley, Bosch, all these sorts of brand names. So we're not so much, as I said, we're sort of building a miniature version of one of these industrial conglomerates, to be honest. So in closing, just talking about next steps, here on the right, there's a picture. If you haven't seen one before, this is what anode looks like. So the final material, the active anode material, is coated onto a copper foil, which is your current collector. That's wound up, that's your anode. This is the bit no one talks about because, and quite rightly so, the lithium, the nickel, all the other parts of the cathode, the manganese and all the other parts, they have all critical supply chain issues as well. But the forgotten side, on the anode side, is actually a big volume. It's actually the largest single volume of the battery. And we have an Australian company that's taken its technology out to the world, and we're kicking some goals, frankly, behind the scenes that is starting to emerge. What you'll see coming up is more of these goals becoming public. And what you see here is a trial of our anode on a pilot plant for a global performance automotive customer who's testing the material, and they're one of tens. The qualification processes are underway with autos and OEMs. We have a trial mine to extract about 25% of our commercial production that we should be getting our teeth into in the next few months. We have scaled up our plant. We've got this new EVA plant under construction in Sweden, which should be commissioning towards the end of this year. The development talks are coming up, the DFS, various forms of mass production, and in the last couple of days, we've also announced positive feasibility studies on building extra refineries in the UK. The UK has got a big agenda. It's very, very clear all the way to the top. Boris Johnson is driving the rest of the government towards trying to electrify their mobility industry, their automotive industry, which currently employs about 800,000 to 1 million people. And it's a very, very important industry. If they're going to keep it, it has to electrify. So between that, the microgrids, the aerospace, the drones and everything else, that entire industry, they're trying to have in a post-Brexit world their own supply chain, and they have zero graphite naturally in the country. So we're working with them to look at opportunities for us, and this is one of many opportunities Talga has to grow with our core material and operations in Sweden, to have different refineries in different countries, or you could say different continents, to supply material that's needed for the world, because this is the cleanest, best performance material. This is the cleanest way to do it, and it's very, very scalable. So it'll continue to grow with the market. And with that, I will let us get back to the rest of the talk. Thank you.